So I should be recording now, and I will post this. Um, we have Paul Peterson here today, who um, is going to be a tutor for our class, and this is the first time that I've had a tutor for a course that I've taught. So Paul, can you introduce yourself and start us off with who you are and how you're going to help us?
Definitely. Yeah, so my name is Paul. We actually usually did not like specifically assign tutors to classes in the past, and we've kind of changed it up a little bit once we started going online. So just kind of give you my background. I've been with St. Paul College for 10 years now. I started out as a math tutor, and then for the last 8 years or so, I've been actually tutoring chemistry as well. So I have seen I don't know. I've seen a lot of the, stuff that students have done on campus here and, just the way things have changed over the years in terms of the homework platforms they've used and the labs they've done. So, um, so I guess if you have questions on, it doesn't even have to be just chemistry stuff. If you have questions on how to use some of the technology, maybe one thing, for example, I saw last semester a bit was people weren't sure how to type in some of the answers. Someone would get a little screwy, like, um, for example, trying to make a subscript and a superscript at the same time, stuff like that. If you find yourself with questions like that, definitely I'm there if you have questions on that. So I just want to give you all a couple kind of bigger overview of kind of my hours and what I can do to help you. Um, every meeting that I have would be on Zoom. Um, Having said, and by the way, we use Zoom just because that's for the most part what instructors are using. If for any reason you really, really want to use some other platform for talking to me, just let me know and we'll see what we can do to figure that out too. Um, I'm available 9:30 to 6, Monday through Friday. Same thing there. If you find yourself like, if for the most part you find yourself working like, let's say you have a job and you work till 5:30 every day and you just can't come in and get tutored during those hours, please let me know so we can make something else work as well. um, you can get you can sign up for up to 1 hour a day, 3 hours a week. So you could sign up for 3 different days if you wanted to. um, my link, I don't know, is my link schedule link already in the syllabus or in the D2L?
Yes, I put it on the syllabus, which is on D2L. So
Perfect. So yeah, if you forget, it's pretty easy actually. It's Paul-Peterson at or Paul-Peterson dot you can book me basically. So um, same thing there though. If you forget or if you have any questions on that, the easiest thing to do is just email the tutoring email because that's just tutoring at stpaul.edu. So if you ever had questions and you weren't sure how to get in touch with me, just just email me. That's probably the easiest way. But definitely you can just directly schedule a session on my website. So, um, but like I said, um, I'm available most of the week. I love doing chemistry. It's a lot of fun. Um, and if you have questions on labs too, feel free to ask on that. Sometimes I think once in a while, you might have to do Excel or something with calculations as well. So if you get something like that, definitely you can ask on that too. Or if you want to use Logger Pro to make a graph or anything like that, you can definitely ask questions about that too. So I guess what I would say is if you're not sure whether it's something you can ask, please ask. It is probably something you can ask. So, and I'll be honest, if it's more math than it is chemistry, like once in a while someone has a question on logs or they have to do some math and chemistry and they're like, I haven't done this for 5 years. We can definitely look at that too. Because like I said, I do math as well. So.
that's great. Anything else, or because that was a really good introduction? I'm really glad to have you with us this semester. I guess it's two months in the summer here, so um, I appreciate it. And now we have 9 participants, so the room has grown. So um, I guess at this point, I'm gonna share a screen and I will start going over some of the things that I wanted to talk about. First, let me just pull up I'll share my web browser first because I just made a few changes to the D2L course. And of course, I can't see to get everything set up so I can click on things. So now in the course, what I just did, I just want to go through. So we have the course information. We have the syllabus. I made a slight modification to the syllabus and just added a lab. I think lab 5, I forgot to put the due date. So I just updated to that today. Make sure that you check out the online textbook here. It's free. You can get a hard copy, used or new at the bookstore. And then please make sure at this point, it looks like 19 students have enrolled into the WebAssign. This will be our online homework format. So I believe almost everyone has signed in, but if you're encountering issues, which I just encountered an issue myself and just got off the phone with WebAssign, so it does happen. So just shoot me an email if you have any issues enrolling in the class. Right now, all I have is a chapter 1 assignment posted, and I will post chapter 2 and 3 assignments on WebAssign probably most likely tomorrow. I did just post the chapter 2 podcast or online lecture. So that is here. And I also included the notes with the Word documents, which includes the practice problems that we go through in the lecture. And then I included the PowerPoint presentation too. So this is the lecture. And then under lab, right now, all I have is the safety training, which most have completed. I will go through and get that in the grade book probably by tomorrow. Lab 1, it looks like some of the students have actually already completed lab 1. So a little bit ahead of the game there, but good job. I don't think this is due for a little while, so you have a week and a half before that's due. And I will post lab 2 and 3 tomorrow. And on lab 1, you'll notice that I have a introduction video, and I will make sure to do the same thing for all the upcoming labs. These videos were large because I did them from my phone, but now I have a better recording format. I think that should make these files a little bit easier to manage. And there was an issue with this video earlier on because of the size, but I think that's corrected. And today I added this extra resources tab. So here is where I'll post the recording for the office hours. And then I have also posted a PDF document with the slides that I intend to go through today. So, and then in these slides, there will be some practice problems that I will not go through, but they are also there for extra, if you want to go through these slides, there's more problems for you to go through. And I'll show you this as we go through it. I also posted some YouTube tutorials. So there are lots of great teachers out there, and I'll continue adding to this as I find videos that are related to the topics that we are going through with our textbook, because there's lots of other textbooks and there's lots of other instructors out there teaching this. So here are some links to 4 different videos on significant figures. I'm going to go through significant figures again today because I've already had questions on that. And then we have some dimensional analysis examples from chapter 1. And then at the end of chapter 2, we introduced the moles, which I will go through today a little bit too. But here's a whole bunch of links for more examples of how to work these problems out and describe the concepts in more detail. And then I think that I added one last thing here, and that was these practice worksheets and problems. Now these are not due, and these I've used from a previous course. So you might notice the course name is different, but the problems are still directly relevant. So this is practice. These are only for practice. These are not due, but I have just dimensional analysis worksheet. So you can print this off, and then there'll be problems on here. And I encourage you to work through the problems yourself on this worksheet. For dimensional analysis, I have a table here. And then after you go through it yourself, you can check your answers with the key, which I provided here. So these are just for your own practice, just more problems to go through. I want to give you lots of different examples, just because the exam 1 is coming up next Monday, I believe. So that's coming up quick. So there's plenty of examples here. Feel free to use these as you please. And you'll note that some of these have different names. These have been donated to me from other faculty members. So just ignore the names on these practice worksheets just because they come from a different source. But definitely take advantage of them. They're just more practice problems, more ways to review the concept. So those are the new things that I posted today. And then based on, let me just check the participants, make sure I got everybody in here before I start the PowerPoint. It looks like everybody's in and nobody's waiting. Okay, so at this point, I'm gonna switch over to more of the guided demo. And I think I'm gonna have to reshare my screen with this one. Okay, so far I've had some questions on significant figures. So I plan on just going through a different series of slides. So I actually Penny Starkey, I used her chapter 1 podcast. So she went through uncertainty and significant figures at the end of the chapter 1 podcast. And then I also went through the mole concept yesterday, which from past experience is something that I've had a lot of questions. And since I just posted it yesterday, I was going to go through these concepts again, but in a different format. So these slides you have not seen before. We're going through the same topic, but just with different slides, different problems. And then I posted these slides online already, so you can use these as a reference too with all the other materials. So just let me just see. So you should be seeing my screen now, and I'm gonna blow this up. And so one thing we went through at the end of chapter 1 was accuracy and precision. Now these are two different things, and they are ways to describe uncertainty in a measurement. So accuracy is how close a measurement is to the actual value, whereas precision, that's how well a measurement can be reproduced. So let's say this example here, I have 2 students, they measure the density of water in the lab. So you are doing a density measurement, I believe, in the lab yourself with lab 1. So let's say student 1, they take 3 different density measurements. I have 0.92 grams per ml, because that's mass over volume for your density, 0.91 and 0.93. So then I take the average of those 3 and I get 0.92. Now student 2, we're getting a little wider range here from 1.17 all the way to 0.89, and the average is around 1.101. So the questions here, the actual, we know that the actual density of water is 1 gram per ml. So given these 2 students, which student is more precise? So precision, that would be, looks like student number 1, because it's not as accurate because we're 0.08 grams per ml away from the actual value here, but the measurements themselves are very close together within a very small range. So this student is more precise, whereas student 2, you have a wider range of values, so it's not a very precise measurement here, but they are more accurate because 1.01 is much closer to the actual density of water than 0.92. So these are the types, this type of problem could be on an upcoming exam. So and then uncertainty and measurements, there's 2 types of numbers in science. There's exact numbers. So these have defined values. So we know that 1 yard equals 3 feet. And then there are inexact numbers, and these are measured by any method other than counting. So length, mass, volume, time, speed. So inexact numbers have uncertainty. So they are not known with absolute precision and accuracy. So this is an example of an inexact number that has uncertainty, and then how old is a 65 million year old dinosaur bone after 3 years. So significant figures, they're reported in a number. The last significant digit in a measured number is referred to the uncertain digit. And then the number of significant digits in a measured number reflects its accuracy and precision. So, and then the instrument or the person that is making the measurement can also influence the accuracy or precision. So look at, in this particular example, I'm measuring a 2 gauge flash disk, and on one side, I have a centimeter ruler marked with just 1 or 2 centimeters. But if I measure with this bottom ruler, I will have more certainty in my measurements because now I have the millimeter mark included in there too. So I can get even further closer to the, I can get a more digits added in because of the millimeter marking on this ruler, as shown here. So if I use this ruler, I'm less certain, but if I use the bottom ruler with the millimeter marking, I'm more certain because I can report my number to more digits. And then, so this would be 2.5 plus or minus 0.1 centimeter because that's the uncertainty. Whereas this one, I can get down to maybe 2.47. So I added another digit, and then my uncertainty will be plus or minus 0.01 because there's no other little markings in between there to give me certainty at that last digit. So, and then this is just showing if you measured, weighed a tennis ball using 3 different scales, the scale will report a different number depending on how precise or accurate it is. So if you use a very, very high-end analytical balance, you can get the very four places after the decimal place in terms of your certainty. So, and then in lab 1, there, we use graduated cylinder. So I just wanted to point, this is a joke, like he has a graduated cylinder and this other one didn't. So what is the reading on the graduated cylinder? So we read the bottom of the liquid's meniscus here. So that's where you would, for lab 1, you're gonna, I believe you use a graduated cylinder and you might have to measure uncertainty. So I just wanted to point out that on a graduated cylinder here, this is an ml, so I can get 40 mLs, 41 mLs, so 41 point something, that something would be my uncertainty. And that could be what, 41 point. So I can get between 44 and 45 here, and maybe it's 44.7. So that's how you would read the certainty on a meniscus for your graduated cylinder. And lastly, I can't see the top of my slide because of the Zoom thing. These are some rules that are presented in a different way than Penny Starkey presented the rules for significant figures. I do like the OpenStax textbook where it has the leading and the trailing zeros, but here's just a list of 6 rules that if you follow these rules, these might be helpful too. So basically rule number 1 for sig figs, all non-zero digits are significant. So zeros may or may not be significant. Rules 2, zeros at the beginning of a number are not significant. So this one is only 2 sig figs. These are after the decimal point, these 4 zeros, but they are not significant because of the beginning of the number. This one, 0.015372, has 5 sig figs. So this 0 is not significant. Now here's another rule, rule number 3. So zeros in the middle of a number are significant. So here, this is kind of sandwiched in between a 2 and a 1. So this would be 5 sig figs. And then in this case, we don't have a decimal point after the 201, but we do have a 0 in between a 2 and a 1. So there is 3 sig figs because it's in the middle of a number. So the other rule about zeros is zeros at the end of a number with a decimal point are significant. So here we have lots of zeros before the digit, so 3 and 5, but we have 2 zeros after, and these are after the decimal point. So this is 4 significant figures. Whereas this one, we have zeros in between 2 digits, 1, and then we also have a 0 here after the decimal point. So this, all the zeros here are significant. So I have 6 sig figs. And I think rule number 4 and rule number 2 are the ones that are the trickiest that I've seen so far. So these are the ones that are good to remember because it will give you a different answer on your test. So here's another one. 5 zeros at the end of the number without a decimal point are generally assumed not to be significant. So this is a tricky one too. So this one, I have a 0, but I don't have a decimal point there. So the only significant figs are the 1, 6, the 3, and the 2. Whereas here, I have 1, 6, and 3 zeros without a decimal point. If I had a decimal point there, all 5 of these would be significant. But because I don't have a decimal point, there's only 2 numbers that are significant, the 1 and the 6. And now this, in some cases, would probably be easier to write in scientific notation. And I believe that's the way that it was presented in the chapter 1 podcast. And then the final rule, exact numbers have an infinite amount of significant figures. And that's, if you're talking about, if you're counting numbers, there are exactly 100 students in the class. You can't have 100.5 students. A dozen is always 12. Pi, that's a number that's always 3.14 to the same. So these you don't have to worry about the number of significant figures with an exact number. And another area where this could be important is in your conversion table. So if you have a conversion table, most likely those are exact numbers, so you don't have to worry about the sig figs coming from your conversion tables. So here I just have some examples. So like 52 cows in a pasture is an example of an exact number with an infinite number of significant figs. So just going through these real quick, this one would have 4, this one would have 4, this one has 3 zeros after a decimal point, so that's 4. This one has a decimal point, so that's 4. This one's 2, right? So this one's a little trickier. 6, 0. This one is only 2 because I don't have a decimal point. This one is 1, and then this one is 4. So why does this matter? More sig figs equals more certainty. So if I can get down to the this place and compared to 500th, I'm going to be way more certain with this measurement here. So that's to the plus or minus 100th, whereas this is to the plus or minus 1. So I'm more certain on the 1 with the decimal point. Okay, so here's an example of measuring fuel efficiency. And then so I'm just doing a problem and I have fuel efficiency and I punch this in my calculator. And now the question is, how should this number be reported? Well, this is a division problem. So now we've went through those 6 rules. So this is too big of a number and we're not going to report it to that many sig figs. So now we have to follow the rules for multiplication or division. So there's 2 rules, multiplication and division. The result can only have as many sig figs as the original number with the fewest sig figs. So if I'm timesing 5.376 times 3.21, the fewest sig figs is 3.21. That means that my final answer has to be with the fewest sig figs, 3 in this case. And same thing here, I'm doing a division, same numbers. I have 3 sig figs with my answer, but of course it's division instead of multiplication, so it's a different number. And then the other rule, that should say number 2, addition and subtraction. The result can't have more digits to the right of the decimal point than either of the original numbers. So here I'm taking 2 numbers and adding them together. I have 5.7 and 5.1276. When I punch that in my calculator, I get this long number, but I can only go to 1 decimal place after, because that's what I had. So I can't have any more digits than that to the right of my decimal point. So I'd have 10.8. And same thing with this one over here. I have 2 decimal places. So I have 2 digits to the right of the decimal point. So my answer can only have 2. And then here's just another rounding. So we went through that, but just again, another, just above 5, you round up, below 5, you round down. So in here I have some problems, and I posted the slide deck on the extra resources tab. So I'm not going to go through these. I will let you work these through, but this just more problems and examples for you to work through to become familiar with the type of problems you'll see on an exam. So here's a couple more. So I gave 5 practice problems here. And then, so that's topic 1 that I wanted to go through. And I have 5 examples that you can work through yourself for the sig figs portion. Now, the next concept that I want to talk about in a little more detail is the mole. And I just went through this and posted this on yesterday on D2L. and the slides that I'm going to show you here on the concept of mole are again different. So I just two different ways to present the data. So here I'm just asking some questions. Can you see a carbon atom? Can you weigh a carbon atom? The radius is incredibly small. The mass is incredibly small. So what I'm introducing here is the concept of mole. And in particular, there's Avogadro's number, which I don't think I really hit on enough in the lecture yesterday. So that's kind of why I'm covering it again, is we briefly touched on Avogadro's number in that one. But Avogadro's number is basically just like a counting unit. It's just like a dozen. So a dozen is 12. A mole is always 6.022 times 10 to the 23rd units of something. So it could be atoms, it could be molecules, and we go through one problem in the slides from yesterday or from chapter 2. But we'll go through more here. So just like you can have 1 dozen eggs, that always equals 12 eggs. 1 dozen donuts will be 12 donuts. So 1 mole of carbon atom will be 6.022 times 10 to the 23rd carbon atoms. 1 mole of oxygen atoms will be 6.022 times 10 to the 23rd oxygen atoms, and so on. And basically just a mole is a number of something, and that's it. So, and then I go through this in the other slide deck too. So the definition of the mole is based on carbon 12 isotope. So 1 mole equals the number of atoms, and 12 grams of the carbon 12 isotope equals 6.022 times 10 to the 23rd atoms. So, and the definition of the atomic mass unit, so 1 AMU equals the mass of a carbon 12 atom divided by 12. And I talk about this in the detail in the actual podcast lecture, but this is basically the reference in the standard. So now we can use this concept of Avogadro's number in moles to do useful conversions. So just pointing out that, like, if I have this helium balloon, if we look at our periodic table, which we learn about in our chapter 2 lecture, we'll find that helium has an atomic mass of 4.00 AMUs. So this is also, we can get information out of this about, if we look at the periodic table, we see that it has a mass of 4.00 AMU, but that also means that 1 mole of helium atoms has a mass of 4 grams. So this is a very useful conversion. We can look at the periodic table now, look at the mass, and then use the mole concept to do conversions. And then if I look at a copper atom on the periodic table, it has a 63.55 AMU. So 1 mole of copper atom has a mass of 63.55. So different atoms, we're still using the concept of mole, and we always have that many atoms, but since they're different elements, they will have different masses. So, and then here's another represented way to look at how to go back and forth between atoms to moles using Avogadro's number. And then we did do many conversions in chapter 2, going from moles to grams. And that's where we use the concept of molar mass. So I have this on here, and we did a few examples, and I'll just do one again. So in this one, how many gold atoms are there in 1 gram of gold? So I have 1 gram of gold, AU is the nomenclature for that. And then if I look at the periodic table for AU gold, I'm going to find that it has a mass of 197.0 grams, and that's per 1 mole. So now I set up my conversion factor, and my grams will cancel, and my answer will be left in moles of gold, and I will have 0.00508 moles. So this would be equivalent to the division that we did in the way that we learned it in the first round. But basically, I start with grams, and I put my grams on the bottom of my conversion factor because I know that 1 mole of gold is at 197. And then my grams cancel, and I'm left with moles of gold. So let's look at this next one. What is the mass of 583 Hg mercury atoms in grams? So here, for this type of example, now I'm going to use Avogadro's number. And I think we only had one example in the chapter 2 lecture that I posted yesterday with the Avogadro's number. So here's another example of that. Now I have 583 Hg atoms, And I know that in 1 mole of Hg atoms, so I divide that by 6.02 times 10 to the 23rd, because that is Avogadro's number, and that should say Hg, that should be Hg, so that was my bad. Hg atoms, because that's not aluminum. So I will effectively divide by that, and then I will be left with moles. So that I'm doing this in 2 pieces. So I convert it to moles, and now I look at my periodic table, and I know for Hg, mercury, that's 200.6 grams, and that's the molar mass. So then I times that by the grams per the mole of Hg atoms. So the first thing I did was I went from atoms to moles. And now the second thing I did is I used my molar mass from the periodic table. It's a simple one this time. And I just times that by the molar mass, and that's going to give me the amount of grams. So 583 Hg atoms equals a very, very small amount of grams, 10 to the negative 19th, 1.94. And make sure there's 3 sig figs there, so there's 3 sig figs here. So significant figures are important. So I have 3 examples here that I will let you work out. So these are just more practice problems, very similar to what we just saw on the last slide. So you should be able to, except I made the one mistake. This should be Hg, not Al. That's because it's Hg atoms. That's the only mistake there. So these are 3 more practice. Actually, I do go through these. So I have 3 more examples. I'm not going to go through each of these. So if you want to go through these in your free time, I posted these with the answers. So these are more examples of how to use Avogadro's number or moles. I have these worked out for you. So here are some practice problems. So I do have some practice problems. So I went through this one, and then I'll let you use these as more examples for your own resources. And then here's some more practice problems here, where this one you're going to have to calculate the molar mass of calcium PO4 or work out so there's lots of nice examples here. There's one with the ocean. Okay, so I also worked these out here too. But I think I'm not going to go through all of these. The one that I do want to go through here is just this molar mass concept again. So now we have a more complicated compound. It has calcium, phosphorus, 4 oxygens, and this subscript 2 here. So we're going to talk about how this all works in the upcoming chapters and how to name this. So I'm not going to talk about that now. But now let's say we have this compound and we want to calculate the molar mass. So the way to do this is I'm going to go to my periodic table, and I'm going to look at what is the mass of calcium in AMUs, and that's 40.08. And I have 3 calcium, so I have to times the 40 times 3. So then I'm going to do the same thing for my phosphorus. And that, if I look at my periodic table, is 30.97. I have two of those, right? Because this subscript goes to 2 P's. So I times that by 2, and that's 61.94. And then now here's where I have 4 oxygens, but I also have this subscript here. So that would be 8 oxygens. So that's kind of the trick here, is that the 2 is in parentheses, applies to all of them. So my mass of oxygen is 16, and then I have 8 of those, so I times those. And then basically I sum and add all these together, and then I will have my molar mass, and that will be in grams per mole. So this is the first step of many of these conversion problems, as we saw in the lecture yesterday too. But I just really want to make sure that you're able to calculate the molar mass for some of these more complicated compounds and have that understood, because for lots of problems, you'll have to do this first and then get your molar mass calculated. And then you can use your molar mass to go from grams to moles and moles to grams and back and forth. And then I have some other problems here. And I do I have the examples written out, so you can use these as just more practice examples. So, and then on this last page, so here are the examples where I didn't put the answers, and you can use these. So you can use these examples here as more practice, and then try to answer these ones. What is the molar mass of ethanol now? And then so this one should work all together too, if you try working this one out, because here I'm starting with the molar mass of ethanol, and then I'm going to have you figure out what is the mass. So then now you have the molar mass, and then you know the moles here. So then you're going to convert to grams. And then in this bottom case, how many molecules are in 9.32 grams. So then you're starting over here at the grams. You're going to have to use your molar mass that you calculated in number 1 to get to moles. And then you're going to have to use Avogadro's number to calculate the number of molecules. So this is a really good example. And if you know how to, I would recommend going through these types of problems and just making sure you have these down for the upcoming exam. So, and that's all I had for my practice sort of guided lecture section. These are posted. I will post this on afterwards, as soon as I figure that out. Are there any questions at this point that aren't related to what I just went through? Looks like we have.
Yeah, this is Yazani. I missed the first 30 minutes before. Is this recorded, or I can go back and look at it maybe? Or
Yes. So I am recording this now, and I will post this along with the slides that I went through. The slides are already posted, and I'll post a video right next to where I have the slides. I added a new tab called Extra Resources, and that's where you'll find this video. And please let me know if there's any issues getting this uploaded, because last week I did have an issue with the video, and I really appreciate that somebody pointed out right away, because I was able to fix that.
Thank you. Thank you.
So the only other thing I could think is exam 1. I'm looking at the syllabus next. I believe that's next Monday, right? Is when we have that.
Yeah, next Monday.
Okay. Yeah, I'm just double checking so next Monday, and I'm deciding on when I'm going to make that window available. So I think you'll only have 120 minutes, 2 hours to take exam 1, probably 50 questions or so. I'm still deciding on that. I will post more information probably tomorrow, because I'm going to work. I have to decide how much of chapter 3 I want to put on the exam. So I'll post that lecture tomorrow. And then after that, I think I'll have a better understanding of how many questions and where you should focus your attention. But chapter 1 and 2, definitely, that's going to be the bulk of the exam. And then we're only going to get into maybe the first, because I think there's actually 6 or 7 sections in chapter 3, and we'll probably only get through maybe 2 or 3 of those. So I'm still deciding, and I'll get that figured out by tomorrow. And I will also post lab 2 and 3 tomorrow as well. So lots of stuff tomorrow. Looks like a rainy day, a good day to post lots of stuff online and make videos.
Tori, can I ask a question about the exam?
Sure.
Can you tell us what we'll be allowed to use in terms of, I know there's like a lot of charts with conversion factors, in terms of if we'll be able to use parts of our notes or if we're expected to memorize everything?
So I think we definitely will have your calculator. So you want to make sure that you have a scientific calculator. And I am still deciding, because in the past, what I've done is I've had, so it's harder online, because in class, when I do an in-class, teaching in class, I give like maybe a little note card where you can have a little cheat sheet, but that's harder to do with an online class. So I haven't thought of a convenient way to make like sort of like a simple note card sheet. So the way around this, I'm thinking at this point, and this could change, because I was thinking about asking other professors here at St. Paul colleges for their opinions, was that if there's a conversion factor or a table, because like this dimensional analysis, you will need to know what the conversion factor is. I think I will post that. I will make sure that you have the correct conversion factor for that problem. At this point, that's what I'm thinking. But if I decide to change this up, and there's some way to make a note card, sort of a short little thing to put some equations on, if other instructors have examples of how that can be done, to avoid the cheating issue with the online class. So that's kind of where it gets tricky with the online class, because in class I can proctor and watch the students, and I can see that, what they're looking at, and I can check their note cards if something looks suspicious. But that, I haven't figured out a good way to do that online yet. So that's kind of what I'm thinking, and I know I didn't give you a definite answer, but within the next day or two, I'll post an announcement and get this worked out because it's been on my mind too. So I appreciate the question. Anything else?
Yeah, you said the day of exam is on the 15th.
Go ahead.
Time. What's the time?
Sorry, can you repeat your question?
You said the day of the exam is 15, but you didn't say the time. Which time? Like,
Yep. So I think, so this is where I was going to reach out to other instructors and professors here at St. Paul College to see what they do. My thought was I was going to make it open from 6 a.m. in the morning to midnight. So you would have that window on Monday to take the test, and then you would only have 2-hour period within that range. Does that make sense?
Yeah.
Does anybody
Yes.
have any major issues with that time range right now? Just
Yes, I do.
you do?
Like,
What
yeah.
and what was your suggestion?
My suggestion is that other professors, they kind of open it in about 2 or 3 days because some people work like from 6 to maybe 10 on that Monday. It makes it hard for them to take the test because it's open for just 1 day. So
Yeah.
I suggest that we open it for like Saturday, Sunday, and Monday, or
So-
Monday, Tuesday, and I work that day, so it's not gonna work for me. I'll be
Okay.
so anxious.
So this is in the past, for past classes that I've taught, I have had logger windows. It was recommended to me at St. Paul College to only make the exams open on one day because we have multiple sessions of this general chemistry 1 open. So that's where I'm receiving the guidance on restricting it to a 1-day window. I understand where you're coming from, and if you have other obligations on that date, that's going to make it hard to take the exam. So at this point, I'm going to reach out to other instructors here at St. Paul College, just because I don't want to overstep my bounds and make a wider window for the test taking than other professors are doing. So I'm going to be consistent with what they're doing. But what I've heard so far is that we typically do a 1-day window. And that's but I will be open to, if you have a circumstance that arises, I will be flexible, and I'll make sure that if you tell me in advance about a particular situation, I'm going to make sure that you're able to take the exam. So don't worry about it if it looks like it's impossible to take right now. We'll make something work.
Okay,
So-
thank you.
You're welcome. Any other questions?
Tori, if we have questions on specific homework problems in the WebAssign, can we email you or?
Yeah, I
when-
guess, yeah, why don't, if you, feel free to just shoot me an email with questions. And if lots of students have questions, one thing that I've done in the past is I won't answer it immediately, or maybe I will answer it immediately to you, but then I'll post it so everybody. So what I like to do is if a student does ask a question, and most times if one student asks a question, I have probably 2 or 4 other students asking a very similar related question. So I probably will, in the past, of what I've done is I'll respond to that particular person, and then I will try to make this answer available on D2L in some format or another. In some cases, it's through like the Zoom session like this. In other cases, it could be through me just writing a problem out on a practice worksheet and giving another example that way for you. So I could definitely do that. Anything else?
Yeah, I have a question about the chemistry lab kit. What are we gonna do? Do we have to record ourselves testing with the lab kit?
Oh, okay. So this is a good question. And we only have one lab posted. So for lab 1, we have 4. The last 4 pages. My daughter's crying right now. I just want to make sure my wife is. I'll be right back. Okay, so I'm sorry about that. So for lab 1, what you'll see is that there's 4 pages. The last 4 pages is what you'll want to submit to the assignment Dropbox. Does that make sense?
But do we have to test it, the kit that we got from the college? The lab kit?
So you'll pick up the lab kit, and the first thing you want to do is do the safety contract and the safety quiz. And then lab 1, I give the introduction and explain the materials that you'll use. And the first 4 pages of the lab packet explains the protocol, and you will perform the experiments, and then you'll record your data on the last 4 pages of the packet. And then you'll submit those last 4 pages with your answers to the assignment Dropbox, which is already posted for lab 1.
Oh.
And I guess, does that answer your question?
I know. I was asking if we're gonna record ourselves or we just record the answers we get when we were doing.
So yeah, you don't have to record yourself doing the experiment.
Oh, okay. Thank you.
So that was a simple. Yeah, that was a simple.
Yeah.
I get it. Okay. Any other questions? Okay, I guess with that, I will wrap this up. The one thing that I'm thinking about is that you have the exam coming up on the Monday, and it would probably be really useful to have a review session. I just don't know what the best way, because I may not even have to be involved, so you could all just have a review session without me. I don't know I don't know what some thoughts are on that, but I guess if you have any suggestions about group review sessions for the exams, shoot me an email and let me know.
Yeah, that's really my question is there any like a group review that we can do, like a group study sometime? Because it's difficult if you are not in a group, you don't know what, sometimes you have an idea. If somebody say, hey, let's, if you don't understand maybe some little things, if you're in a group, it's easier, you can help each other. So
Yeah.
is that possible?
So yeah. And so maybe just what I'm thinking right now, if this could change, is maybe I think Saturday, maybe I could just use my Zoom account and I'll set up a session on Saturday. Maybe I'll send out because now I know how to do these anonymous polls on D2L. I set one up to talk about deadlines. So maybe I don't know what time of day would work on Saturday, but we'd have to figure out what time of day on Saturday would work best for everybody. And then I could just host a Zoom session. And then I think if I put the Zoom session on, now you should be able to do breakout groups and talk to other students too. So maybe I'll just plan on setting up a Zoom session on Saturday. I'll solicit some advice for times. I don't know, morning or evening. So it's a Saturday, or it could be Sunday too. I just wanted to do it probably on the weekend because hopefully people will have less people will be working on the weekend. So that I'll send more about this later, but that's kind of what I was thinking about. Maybe just I'll put a Zoom session on and we can use this as our way to review problems for maybe an hour or two on Saturday or Sunday, depending on what people think.
All right.
Okay. So I guess if I don't answer your question by Wednesday in an announcement, just make sure to send me it again. So I think I have everybody's questions here, and I think I'll be able to answer them by Wednesday about the exam, the timing of the exam, the window, and then some other questions too that we have about the review session. So I'll have this all posted and updated on D2L hopefully by Wednesday. But I do want to have a review session, and I'm going to look into what other instructors here at St. Paul College do. So I'm following the rules of the online exam taking from St. Paul College. All right. Okay, well, thank you all for attending, and please let me know, let Paul or I, because we have Paul available to us too, so please make sure to take it. He's gonna be a great resource, so I'm I'm sure he'd be happy to have his schedule filled up. So please make sure to utilize that resource. With that, I guess I'm going to end the session, and you should see it posted soon. So thank you.
Thank
Have a
you.
good day and be safe.